Okay, welcome to class. Today I thought I'd go over homework because it seems like that's valuable for some people. So I'm gonna go do the homework questions first, sort of like I would do in a regular class setting. I usually take up homework questions and then I'm gonna talk about, and then tomorrow will be just a straight word class. So your homework, I asked you to complete on page 14, complete number 1. So these were my questions from yesterday that we did, and we got up to part E. So part F, determine the size of an external angle. Well, I know that the size of an external angle is the same as the size of the central angle. So basically, it's the same answer as part A, right? It's just 360 degrees divided by 8 because n is 8. So I'm going to get 45 degrees. But then it says draw an exterior angle and label it. So the formula is easy to understand. You have to know what an exterior angle is as well. So once again, maybe what I'll do is I'll do this in red. This is a central angle, right? Central. That was from yesterday. This is an interior angle. That was from yesterday. And now we're going to draw an exterior angle. And an exterior angle, I just pick any side that I want. Why don't I pick, I don't know, I'm going to pick this side. It's kind of far away from anything I've drawn before. And all I do is just draw this side, take any side you want, and just keep drawing past the shape, right? If you just extend one of the sides beyond the shape, the angle created is going to be the exterior angle. And these are the same size. So this is 45 degrees. And this is what we call an exterior angle. Exterior means outside. And this angle is outside the shape. Interior means inside. We can see this angle is inside the shape. Central angle, this angle is coming from the center. Exterior, this angle is outside the shape. Okay, so I determined the size of the exterior angle. It's 45 degrees. I drew it. Now I have to calculate the number of diagonals. All right, calculate the number of diagonals and state the number of lines of symmetry. Okay, well, I'm going to leave this one. Sorry, I'm going to leave. I should have read ahead. Leave for tomorrow. Calculate the number of diagonals. Now, it doesn't say to draw them, which is nice because I already have a lot going on here. So the number of diagonals, if you look at your previous pages of notes, or if you look at your formula sheet, the number of diagonals equals, I'm going to use the formula, D equals N, well, N is 8, N times, in brackets, N minus 3, okay, and then everything is divided by 2. Okay, in the formula sheet, it shows you the division bar underneath, but I can show the division bar this way. So that gives me 8 times 5, right? 8 minus 3 is 5 divided by 2. So that's going to give me 20 diagonals. We saw with the pentagram that the number of diagonals was equal to the number of sides, but that's not always the case. So the number of diagonals is 20. Okay, I'm going to leave the lines of symmetry till tomorrow because I haven't talked about them yet. Sorry, I shouldn't have told you to do that one. Yesterday I did number 2, so go back to yesterday's video or notes if you want the answers to number 2 explained to you. I asked you to do page 15, number 3, 4, 5. So I'm going to go over those questions. I'm going to try and make this a little bigger maybe. Okay, let's see if that should work. Okay, consider the decagon, 10 sides. So I know right away, even though it's written, I always like writing my n equals 10, just to keep reminding myself that n is 10. Determine the size of an interior angle in the decagon and label an interior angle with its size in the diagram above. Okay, well, those are interior angles. These are probably the hardest ones to calculate, the most involved, because what I have to do is I have to find the sum of all the interior angles and then divide it by the number of sides. So one interior angle, that's going to equal, I take my 180 degrees times it by n minus 2, 10 minus 2. Then once I do this, I'm going to divide it by, it's a complicated formula, divide it by n. Okay, so once again, the formula, it's right on your formula sheet. One interior angle equals, so right from the formula sheet, we take 180 degrees, we times it by n minus 2, and then we divide everything by n. Okay, so that's what I did. N is 10. So this becomes 180 times 8 divided by 10. And now I'm going to pick my calculator up. And I get 144 degrees. Okay, so that's the size of an interior angle. And remember, these are your interior angles right here. The more sides, it seems, the more sides there are to a shape, the larger the angle gets, right? And this is an interior angle. Calculate the size of the exterior angle. Okay, that's really easy. Exterior angle from the formula sheet is just equal to 360 divided by n. Those are super easy, right? So 360 divided by 10, that's just going to equal 36 degrees. Okay, the harder part might be drawing it and labeling it. So let's see. Oops, where did I lost my ruler for a sec. There it is. Okay, so I'm going to take this side and just extend it, right? So that means that this angle, 36 degrees, and that is an exterior angle. Okay. Number 4. Let's take a look at number 4. So once again, the number of diagonals is equal to n times n minus 3 divided by 2. So for a pentagon, pentagon is the 5-sided shape, right? And if you're in doubt, remember you can look back on page, what page was it? Page 8 had all the shapes with the names. Pentagon is the one we were studying this lesson. So I know that n equals 5. So the number of diagonals for a pentagon would be 5 times 5 minus 3 divided by 2. And that would simplify to 5 times 2 divided by 2. And which one is that? Well, that would be D. All right, last question. You've probably realized by now that your best friends in this lesson are a ruler and a pencil, right? A ruler is needed to draw the exterior angles and also the central angles and the diagonals for sure. So let's take a look at this last one. In a heptagon, a 7-sided regular polygon, calculate the number of diagonals and then draw the diagonals. Okay, well, first of all, n is 7. So the number of diagonals I should get should be D equals, I'm using the same formula I just used up here. It'll be n times n minus 3, all divided by 2. So that will simplify to 7 times 4 divided by 2. In my calculator, 7 times 4 divided by 2 gives me 14. So the number of diagonals, there are 14 diagonals in a heptagon. Okay, let's draw them. Now, the definition of a diagonal is, it's basically telling you how to do it again, but it's you connecting every vertex to each other vertex. So in a heptagon, there are 7 vertexes, right? Vertices, 1, 2, 3, 4, 5, 6, 7, 7 corners. So what you have to do is connect every corner to the other corners, unless they're already connected by sides, right? This vertex is to this one already, but that's not called a diagonal. That's just called a side. Diagonals actually have to run through the center of the shape. So I'll start at the top. It doesn't matter where you start. So this one's already connected, not a diagonal. Here's my first diagonal. 1, 2, 3, 4. Okay, so I'm keeping count as I go along. 4. Now I'm going to move here. I'm going clockwise. So I'm at 4. This one's already connected. So 5, 6, 7, 8. Okay, I'm at 8. This one, now I'm at this corner. So this one's already connected. I'm at 8. 9 is our 8. That one's already connected. So 9, 10, 11. Okay, now I'm here. I'm at 11, 12, 13, and the last one here, let's see, I'm at 13. Done, done, done. Here's my last one, right? 14. And I'm done. All the diagonals have already been drawn. Once a diagonal's drawn, like for example, the first diagonal I drew is this one. So if I ended up at this vertex, I can't redraw a diagonal once it's been drawn. So you can see all these star shapes and patterns, really interesting stars occur. Because this is a regular polygon, right? Like it's symmetrical. All the sides are the same length. So you're always going to produce these really pretty star shapes in the middle. Okay, so there's my 14 diagonals. That is it for the homework, okay? So I know I've been talking for a few minutes now, but we're going to go back. We're going to finish the last of the lessons, and then I'm going to give you work time. So let's see. The last thing we're going to talk about, the last new thing is lines of symmetry. So the drawing is similar to what we did for diagonals, except lines of symmetry and lines of diagonals are different. Let's talk about a line of symmetry. A line of symmetry in a regular polygon is a line that splits the polygon in half. So there are identical but opposite shapes on either side. So basically, this is the key phrase. A line of symmetry is a line that splits the polygon in half. Okay? So the only thing is, I think I'm going to do another line of symmetry too with a even-sided shape. This is a pentagon again. We've used a pentagon a lot, but notice that for pentagon, n is 5. Okay, so it's an odd number of sides. When you have an odd number, what you're doing is you're splitting the shape in half, and basically the lines of symmetry connect a vertex to the middle of the other side. Okay, notice that when you are done, you have the same number of lines of symmetry as sides in the polygon. For example, an octagon would have 8 lines of symmetry. A pentagon has 5 lines of symmetry. Okay, because if this was printed on a paper and I folded the paper in half, this fold would cut the pentagon in 2 equal shapes, right? So basically, for an odd number of sides, you're going to find a vertex, and if you wanted to slice it in half, the first line of symmetry would take a vertex and cut the opposite side in half, right? So that's one line of symmetry. Here's a second line of symmetry. I'm going to take a vertex, I'm going to connect it to the opposite side, but halfway to the opposite side, right? Okay, that's my second line of symmetry. Let's take my third one, vertex to the opposite side. This one's already been done. Here's my next vertex, vertex to the opposite side. And finally, vertex to the opposite side. And they all meet in the middle there, right? So I'm just going to record this really important note. Notice for a shape, with an odd number of sides, the lines of symmetry connect a vertex to the midpoint of the side opposite to the vertex. Okay, so vertex connects to the side opposite halfway in between halfway at the halfway point of the side opposite, I guess. Okay, now let's do one more line of symmetry example. I want to do one more example for you because I don't want you to get the impression that all lines of symmetry get drawn like this. It's only for an odd number. Okay, and 5 is an odd number, right? Let's try one more. I'm just going to move over to the opposite page here. Okay, so let's try one more line of symmetry. Let's do it for a lines of symmetry for an even-sided shape. Okay, So a number of even sides would be like 4, 6, 8. So example, we will draw a hexagon. 6 sides. Okay, so bear with me. I'm going to try and draw a decent hexagon. Okay, so I'm going to do, maybe I'll use my inches. Okay, 1, 2, 3. Let's draw it down here. Trying to draw them all the same size, right? Let's draw one. And you could use a previous picture if you wanted to. I'm just trying to draw this so that it won't work if I just freehand it because it won't look symmetrical. Okay, so here's a hexagon. All the sides are the same length, which means that it's a regular polygon, okay? And you can just watch this, and you don't have to even redraw it. You could just watch what I'm doing here. So even-sided shape, n equals 6. So there will be 6 lines of symmetry. So let's see what happens. The first line of symmetry will be, I mean, it kind of makes sense that symmetry, because I'm trying to cut this in half. This will be 1, right? 1 line of symmetry. Another line of symmetry will be just cutting in half this way, right? 2. Another line of symmetry will be okay, hang on, guys. Hold on a sec. Peaks. Hang on a sec. 1, 2. I have to make sure. This looks horrible, doesn't it? Hang on a sec. I have to check something for you guys. Yeah, my picture doesn't look good, does it? It looks very weird. All right, I'm just going to keep going with it. 1, 2, 3, 4. And then 5, 6. So you're joining the midpoints and joining the corners. Okay. For an even shape, for an even-sided shape, we join the midpoints of opposite sides and join opposite vertexes to draw lines of symmetry. Okay, so I find the opposite sides and I join the midpoints. And then opposite corners, I draw the midpoints as well. I tried to draw my hexagon nicely, but it didn't really work. I'm going to flip backwards to, let's look at page 8. Let's draw some lines of symmetry. Let's do the square. Let's draw the lines of symmetry on a square. Okay, it's even-sided, right? 4 sides. So I'm going to connect the midpoints of the opposite sides. 1, 2, and then I'm going to connect opposite corners. 3, 4. Okay, those are lines of symmetry. Let's take the 8-sided shape. We'll do one more even side. Okay, so here's an even side. So find the middles of the opposite sides. 1, 2, 3, 4. Okay, so I connected all the opposite sides by drawing lines through their midpoints. Now I'm going to check or connect the opposite corners. 1, 2, 3, 4. 4 and 4 make 8. Okay, let's do one more odd-sided shape. So we did the pentagon already earlier. Remember what we did there? We connected a corner to the side opposite, corner to the side opposite, corner to the opposite side, corner to the opposite side, and corner to the opposite side. Okay, that's how we do odd-sided. So let's do it with the triangle. We should have 3 lines of symmetry. Corner to the opposite side, corner to the opposite side, corner to the opposite side. Because odd-sided shapes don't have, even-sided shapes have 2 sides opposite each other. That doesn't happen with odd sides. Odd sides have a corner opposite to a side. Okay, so that's the difference between odds and evens. Okay. Yeah, this one looks weird. I tried to do my hexagon and just it doesn't look good. All right, I am going to assign now. I'll take pictures. I'm going to assign I'm not going to do those, the algebra problems yet. So I'm just going to assign for you, we'll see, 6, 7, and 8, okay? So homework is 6, 7, and 8. Like I say, I'm taking this nice and slow because these concepts are kind of difficult, right? So do 6, 7, 8. We'll do a little algebra tomorrow, and then we're going to finish up the week. Just some review questions, and then maybe I'll give you an extra assignment if you feel like you want a bit more practice on this stuff, okay? So I'll post the notes, I'll post the video, and get to work on 6, 7, and 8. And that's it for today. Let me know if there's any questions you have, though, before we sign off. Okay, I guess not. All right, so I will post everything and I will talk to you tomorrow.